Good day everyone, we're now going to discuss about Chebyshev's theorem. Who is Pafnuty Chebyshev? He is an assistant professor of mathematics from University of Petersburg in 1847. He became a correspondent in 1874 and a foreign associate of the Institut de France in 1874. He developed a basic inequality of probability theory called Chebyshev's inequality, a generalized form of the Chebyshev inequality. He used the latter inequality to give a very simple and precise demonstration of the generalized law of large numbers. The average value for a large sample of identically distributed random variables converges to the average for individual variables. Chebyshev's theorem. The theorem stated that the proportion of any distribution lying within the standard deviations of the mean is always at least 1 minus 1 over k squared, where k is any positive number greater than 1. The theorem is valid for any distribution of data. It can be used for samples or populations. Formula for k. K is equal to the absolute value of x minus mu over theta, where x is the upper limit of the given interval, mu is the mean, and the theta is the standard deviation. We are now going to have a sample problem. Find the proportion of all the numbers of a data set that lie within 3 standard deviations of the mean. Our solution, k is equal to 3. So that means 1 minus 1 over k squared is equal to 1 minus 1 over 3 squared, which means we will have 1 minus 1 over 9, which is equal to 8 over 9, and it is equal to 0.889. Do you get the same answer? The answer is 0.889. We will now have the sample problem. Find the fraction of all numbers of a data set with a mean of 65 and standard deviation of 4 that must lie between 55 and 75. Let us now have the given. The given is the x is equal to 75, the mu is 65, and the theta is 4. You all know that the x is the upper limit of the interval, the mu is the mean, and the theta is the standard deviation. Let's now first find the k. K is equal to the absolute value of x minus mu over theta. K is equal to the absolute value of 75 minus 65 over 4. So k is equal to 2.5. Note, the value of x is the upper limit of the interval between 55 and 75. Let's now find the proportion. So that would be 1 minus 1 over k squared, which is equal to 1 minus 1 over 2.5 squared. So that would be 1 minus 1 over 6.25. So the answer is 0.84. or 84 over 100. So the fraction is 84 over 100. For the lowest term, that would be 21 over 25. Let us have another problem. Find the percentage of students who scored between 72 and 95. The mean score was 83 and the standard deviation was 3. Let us have the given. X is 95, the mu is 83, and the theta is equal to 3. Let us first find the k. K is equal to the absolute value of x minus mu over theta. K is equal to the absolute value of 95 minus 83 over 3. So K is equal to 12 over 3, which is equal to 4. Let us now find the proportion. So that would be 1 minus 1 over k squared. That would be equal to 1 minus 1 over 4 squared, which is equal to 1 minus 1 over 16, which is equal to 15 over 16. The percentage is equal to 15 over 16 times 100%, which is equal to 93.75%. So 93.75% of the students who scored between 72 and 95. Let us get a sheet of paper and solve this problem. Find a fraction of all the numbers of a data set with a mean of 80 and a standard deviation of 4 that must lie between 75 and 95. You will have 1 minute to solve this problem. Okay, let's answer this problem. For the given, x is equal to 95, the mu is 80, and the theta is equal to 4. Okay, let's find the value of k first. K is equal to the absolute value of x minus mu over theta. K is equal to the absolute value of 95 minus 80 over 4. That would be absolute value of 15 over 4, which is equal to 15 over 4, and eventually it is equal to 3.75. Okay, let's find the proportion. That would be 1 minus 1 over k squared, which is equal to 1 minus 1 over 3.75 squared, which is equal to 1 minus 1 over 14.0625, which is equal to 1 minus 0.0711. And the answer is 0.9289. That would be 9,289 over 10,000. So here are the sources of our discussion today. This is from Next Century Mathematics, Statistics, and Probability by Orines Fernando B. and Jesus P. Mercado. And also, we'll have the sources from Britannica.com. Here are the sources of the images. Thank you very much for watching, and I hope you like the discussion. Don't forget to subscribe this channel. Thank you and goodbye.